Hello everyone, welcome to chapter 2.1. Today's topic is going to center around quadratic functions. And we're going to recall how to find the vertex and identifying whether that's a maximum or a minimum, and applying that to some real-world applications. We're also going to determine whether a parabola opens up or down, along with other transformations. And we're going to work to find intercepts of a quadratic function, or the zeros of a quadratic function. So let's get started. Let's begin by identifying what a quadratic function is going to look like. Typically we have that ax squared plus bx plus c. But any of the following is also true of a quadratic function. You know, it could be something that looks like this. X squared plus 6x plus 2. Looks kind of like our classic form. But we could also have something that looks like this. 2 outside x plus 1 squared. Or even like 9 plus 1/4 x squared. And you should see that the key similarity here is that we have an x squared, and an x squared. That is what makes all of these quadratic. The vertex of a quadratic function is also its maximum or minimum value, and that is just determined by whether or not the parabola opens up or down. Here's what I mean. If we have the classic ax squared plus bx plus c, where a is greater than 0, a is a positive number, then what we have is a parabola that opens up. And we can even say that opens up. And right down here is where we would have the the vertex. We could also call that vertex a minimum in this case. It's a minimum because it's at the very bottom of the U shape. It's at the very, very bottom, lowest point meaning minimum. It's also important that we understand every parabola has something called an axis of symmetry. And really it's just the line that this little U shape reflects itself over. And the equation for that axis of symmetry is negative b over 2a. We can call that the axis of symmetry. Similarly, what we can also have is a negative ax squared out front. Negative ax squared plus bx plus c. In this case, a would be less than 0. That means that our parabola would be opening down, and this is what it looks like for a parabola to open down. We'd have that U shape, and it would be going like this. We're right here at the very, very top of it. We would have our vertex again. But in this case, since our vertex is at the very top of our U shape, the highest point, we call this one the maximum. We also say that this opens down. And right here would be its axis of symmetry, which again would be negative b over 2a. Okay, let's talk about some basic transformations that we're going to see of a quadratic function. We have covered these in our chapters on transformations of parent functions. But we'll go over them one more time. So if we have x plus a c squared, so if we have something going on inside the parentheses, if we have a plus something inside, that means our graph is going to go to the left however many units c is. C units. If we have an x minus a c squared, that means our graph is going to go to the right. Some c units, whatever c is. If we have an x squared, just x squared, and then we have a plus c, a constant at the end that we're adding, that means that we are going to go up C units. And conversely, if we have x squared minus c, that means we're going to go down c units. So there's another last transformation we should talk about. If we have a c in front of x squared, that means that our y values are multiplied by a factor of c. And what that means is, if we have, say for example, 1/3 x squared, we would call that a shrink, and your graph would get wider because every y value would be multiplied by 1/3. Every y value would get smaller than the parent function, and so our values would go out wider. If we had something like negative 2x squared plus 1, we'd have a couple of things going on. First of all, it would open down because we have that negative 2 out front. It would be a stretch. It would get thinner because every y value would be multiplied by a factor of negative 2. So it would go down, but then it would get bigger by 2. And it would also move up 1 unit because we have this plus 1 at the end. Last example, so if we had, say, x plus 2 squared minus 3, well, if we take a look at what's going on inside the parentheses, we have that plus 2. We look back over here, we know that if we have plus c, it's going to go to the left. So we can say left 2 units. And then we have this minus 3. We know a minus at the end means going down, so we would say down 3 units. Okay. Let's talk about the vertex formula. You are going to be asked to find vertexes of parabolas, and here is what I feel to be the simplest way. Every vertex can be found by first finding your axis of symmetry, which is going to be your x value of the vertex, and then by evaluating your function at that x value, f of negative b over 2a. So let's do an example of this. We're asked to identify the vertex and the axis of the parabola. And we're given the equation f of x equals 2x squared plus 8x plus 7. Well, remember to find the axis. If you look back at what we just wrote down about opening up or down, the axis is found just with the negative b over 2a. So what we can say then is, and let's label these, we know we have a, we have b, and we have c. We can put in negative 8 on top over 2 times 2. Negative 8 over 4. So the axis occurs at negative 2. Now what we need to do, this is what we've found so far for the vertex. We have found the x coordinate of the vertex, but we still need the y. So to find the y, we're going to take this negative 2, and we're going to put it in here for all of our x values. So we're going to say 2 times negative 2 squared plus 8 times negative 2 plus 7. And when we evaluate this, we get 2 times negative 2 squared, 2 times 4, so we get 8, minus 16 plus 7. Negative 8 plus 7, we get negative 1. And then we take that negative 1 and we put it back as the y value of our vertex. And there we found our axis occurs when I should verify that this is x equals negative 2. That's the equation of your vertex, or pardon me, the axis. And here is the coordinate of the vertex. Okay, so visually what this would look like. And this won't be exactly to scale, but it'd be helpful to see what we're talking about here. If we had a vertex at negative 2, negative 1, and our parabola opened up, then it would look something like this, with our axis occurring at x equals negative 2. So there we are. Moving on. We'll also be asked to not only find the vertex, but to find the vertex and the x-intercepts of f of x equals negative x squared plus 6x minus 8. To begin by finding the vertex, we're going to start with our negative b over 2a, and we know that we have a, we have b, and we have c. So when we start to substitute all of those values in, we get negative 6 all over 2 times a. And a in this case is a negative 1. So we get a negative 6 over a negative 2, which would become a positive 3. So we can say x equals 3 is our axis. And we don't need to, pardon me, that's our axis. And that tells us that the x-coordinate of our vertex is 3, and now to find the y value, we need to substitute in 3 to our original function. And when we do that, we get negative 3 squared plus 6 times 3 minus 8. And then we get negative 9 plus 18 minus 8. So we get 9 minus 8. We get 1. We put that back into our vertex. And so our vertex occurs at the point 3, 1. Now to find our x-intercepts, remember x-intercepts is another way of saying finding zeros. And we can find zeros by factoring and setting each factor equal to 0. So we're going to say 0 equals negative x squared plus 6x minus 8. I don't really like this negative attached to my x squared in the front because it doesn't let me factor too easily. So what I'm going to do instead is I'm going to take that negative, I'm going to take it and factor it out. So I'm going to have x squared minus 6x plus 8. And then I'm going to have negative outside x minus 4, x minus 2, because negative 4 times negative 2 is positive 8, negative 4 plus negative 2 is negative 6. Now when I set each factor equal to 0, I get the answers of 4 and 2. So my x-intercepts occur at 4, 0, and 2, 0. Alright, there we have found it, our vertex and our x-intercepts. Intercepts, vertex. Alright, beautiful. Moving on. You're also going to be asked to write the equation of a parabola. Writing equations of parabolas. And in order to do this, we need to recall the standard form of a quadratic function, which says that f of x equals some value a outside x minus h squared plus k, where this h and this k are the vertex. They make up our vertex. Excuse me. So if we're to do an example of this, you could be asked to write the standard form of the equation of the parabola whose vertex is 1, 2, and passes through the point 0, 0. What we're going to do here is we're going to take our standard form, our f of x equals a outside x minus h squared plus k, and we're going to use the information that they gave us in the problem to write out an equation once we've found our a value, because that's the only thing they didn't give us. They gave us an h and a k. Remember, the vertex comes from h and k. And they gave us an x value and a y value. So we're going to use all of those. First, we're going to use h and k in order to find our a. First, we're going to use h and k, and then we're going to use our x and y. So, to begin, first of all, I'm going to change this f of x to just writing y, so when we substitute in these numbers later, it'll make more sense. So, f of x and y, again, same thing, so we can say that. We can say y equals a outside x minus, and then I'm going to write my h value, which is 1, squared, and I'm going to say plus my k value, which is 2. Alright, we're getting there, and we know it also passes through the point 0, 0. So we have some values we can fill in for x and y in order to find this missing a value. What we can say then is that our y value, 0, equals a, which we don't know yet, outside our x value, which is 0, minus 1 squared plus our 2. Now, when we start to simplify things out, we get that 0 equals a outside negative 1 squared, because negative 1, 0 minus 1 is negative 1, plus 2. So we get 0 equals 1 squared times a is just a plus 2. We subtract 2 from both sides. We get a equals a negative 2. Alright, that's very useful. So we're going to use a, and we're going to use the fact that h equals 1, and that k equals 2, as we previously discussed. We're going to take the a, the h, and the k, and we're going to put them all into our standard form. So we're going to start with our f of x equals, now we can fill in that a value, negative 2, x minus our h value, which is 1, squared, and then we say plus our k value, which we found to be 2. And there we have it, an equation in standard form with the vertex of 1, 2, passing through the point 0, 0. All right. The last thing we're going to talk about is an application problem. So, say for example that a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given by the function f of x equals 0.032x squared plus x plus 3. Okay, look at that, a quadratic. So we know this is going to be a U shape, a parabola shape. And we are asked the question, what is the maximum height of the baseball? Right off the bat, we can identify a few things, you guys, just by given this question, what is the maximum? Well, remember from the very beginning of this lesson that maximum is a synonym for the vertex. So we know we're going to be finding the vertex of this parabola. And it makes sense because this parabola, there's a positive number out front. That means it opens. Did I copy that down correctly? That's what I did. Okay. Pardon me. This is a negative number out front, which means it opens down. So we know that the general shape of this thing is going to be going downward, which means that when we find the vertex, we are going to be finding the maximum height of that baseball. And we already know everything we need to know in order to find the vertex. Remember, to begin to find the vertex, we need to use that negative b over 2a. And when we take a look at our original function, we see we have an a value, a b value, and a c value. So we're going to use that negative b value, a negative 1. There's no number in front of x, so we know there's a 1 there secretly, negative 1, over 2 times our a, 2 times negative 0.0032. When we substitute this all together, what we get is a negative 1 over a negative 0.064. Which is a positive 1 over 0.0064. And when you put that in your calculator, what you find is that we have 156.25 feet. That's our x value of our vertex. Remember, this is what we're finding is the vertex. Which means it is on our x-axis. That is the amount of feet that the baseball has traveled outward. But we're interested in the height. We're interested in the y value specifically, the height of the baseball. So in order to find that y value, we're going to take this 156.25 and put it back into our function. So we're going to say negative 0.032 times 156.25 squared plus our 156.25 plus 3. And now when we substitute everything out together, if you just throw all this in your calculator, you guys, don't make it harder than it has to be, we get 81.125, and that's answer in feet. And so we find that our vertex our maximum occurs at 156.25 feet out and 81.125 feet up. So our final answer should state that the maximum height of the baseball is 81.125 feet. Alright, that's all I have to show you. We'll see you in class tomorrow.